I will move to actually what I'm supposed to talk about, which is improving genetic connectedness in sheep. The intent that I have here is to give you an overview of what this means, and then we're going to dive in a lot more depth when we go into the workshop sessions and we talk about your specific breeds. So the intent here is to give you some background, if I may. So you've heard this many times, so I'll be quick. Genetic evaluation is all about separating out two things from our phenotype. We want to get a hold of what the genetic merit of an animal is, which basically is estimating its breeding value for a series of traits that matter to us, from the environment, which in our view as animal breeders is just noise that gets in the way of our being able to figure out genetically whether an animal is better or worse. Now, in order to do that separation, it's really all about relationships. And I'll explain a little bit what I mean by that. We have to develop relationships among our animals across different environments, often flocks, in order to disentangle the environmental effects on performance from those that are genetic. And I'll take some time to put together some terminology to explain that. Okay? So, let me first talk about what I mean on forming relationships and some terminology that I often use. Here's a case where our environment is being defined by flock. So we have two flocks, we have two sires, and it turns out that sire 2 was used in both flocks, sire 1 in only one of the flocks. Okay? And let's forget about all the other way the flocks can be related outside these sires to keep it simple. So those environments are, the terminology we would use, are connected because there is a sire producing progeny in common across both environments. So that sire's progeny is serving as a benchmark that we can pull out differences in performance due to the environment versus those due to genetics. And that happens because that sire 2 has progeny in both environments. Everybody happy with that? Okay. Here's another set. We've got 2 more flocks. We have 2 more sires. But it turns out that sire 3 and 4 are only in flock 3 and 4. And sire 1 and 2 are only used in flock 1 and 2. Okay. We call that a disconnected set, because there may be differences in husbandry between flock 1 and 2 and flock 3 and 4 that is affecting the level of performance that we're seeing. So if it turns out that a pair of sires happen to fall into a pair of flocks that don't perform as well environmentally, their phenotypes are going to be worse, no fault necessarily to them genetically, than perhaps a pair of sires that are in a more highly managed or a stronger environment. It becomes very hard then to disentangle whether the differences among those sires are genetic or are they simply the flip of the coin that they found them in a better or worse management group. Connectedness is all about trying to address that reality in our programs, to disentangle the genetics from the environment, given the fact that they can be confounded. Sire 3 and 4 are only in flock 3 and 4. Sire 1 and 2 are only in flock 1 and 2. And those environments may inherently be different. That's the bottom line of what we're trying to do. So, some kind of background, some context of why this matters. Many of our seed stock flocks are small in size, which limits the number of animals we can choose among within our own flocks. And so often and sensibly, we want to step out to other people's flocks to find stock that will suit our need in our breeding program. That's a common entity of what we try to do. Okay? But the question then becomes, how do we do that? How do we fairly compare genetic merit across flocks, given that possibility of that confounding of the environment and the genetics? And it's actually pretty tough in the US because we have flocks all over the place, right? Very different husbandry, different climatic environments. So there's every reason to believe that if sires are only used in one part of the country and a different set of sires are used in another part of the country, on different farms with different locations and management, we may run into this problem of confounding. And so it makes it really hard then to figure out who's truly better genetically. Okay. So connectedness is really about addressing that issue, and it's really all about risk. Given that real possibility, how risky is it if we take a sire in one flock and compare his breeding values to a sire or a potential candidate for selection in another flock? Will our comparisons be robust? Can we be confident that if we choose this sire over that sire, that we actually made the right decision? So connectedness is bounding basically the degree of risk when we do those comparisons. And the strength or the reduction of that risk depends on how strong genetically related animals are in these different environments. But an important caveat, all right? We are not chasing connectedness as a breeding goal. In fact, it can take us in the wrong direction. What we need to find out is, are we connected enough that we're confident that this ram or ewe genetically is actually better than another one based on their breeding values? So it's all about bounding the risk of our decision making. It is different from accuracy. Dr. Murphy did a lovely job of describing what accuracy is. Accuracy is all about, I have a breeding value. Do I believe it based on how accurately it has been estimated? And it's driven by the heritability of the trait, how often has it been measured, so forth and so on. Connectedness builds in an important caveat beyond that. It's asking the question, how much information have I learned about the animal that I'm interested in, given that it's been tested in multiple environments, a comment that Dr. Brito made before. It's about comparison across environments rather than me saying, do I have belief in a breeding value, effectively ignoring where most of the information is coming from. Okay? So they're different ideas. Is that clear as what we're trying to do? Yeah? Okay. So there are several factors that are built into assessing connectedness. Clearly, pedigree or genomic relationships are built in. How much information we have actually collected. What environments an animal was actually raised in. And again, we're actually looking for animals, sires particularly, that have progeny in multiple environments. That becomes really important. And the heritability of the trait. So the big addition with connectedness is that third bullet point. Really, how many environments has the animal had been tested in? That's the distinguishing factor, okay? So some colleagues and I, over many years, I always think back. I have a calendar that I keep, which I have with me, probably a little leather-bound calendar. It goes back to 1993. And I gave a seminar when I was in Scotland about a paper that I fell in love with that finally helped me address this question or think about how connected should things be. And the reason it's heartfelt is the following week, if I flip the calendar, first date with my wife, who still puts up with me, okay? So that's even more important. All right, so I've been involved with this for a very, very long time, okay? And our question that we were being asked was, what is connected enough? You're telling us we need to be connected, but what does that mean? So we ventured into a whole bunch of research looking at that question. This is a bottom line of probably 20 years of work, which is always a little embarrassing. That's all I've done for most of my life, but that's what it is, okay? And so what we see is riskiness along one axis, and we see connectedness value. All you need to worry about is bigger is better, okay? So the more connected we are, the larger that value is, implies greater connectedness. And what you see is there is a huge descent, and then it levels out, okay? So what's happening here is more rams are being shared across farms, creating connections, up until the point where we're good enough, okay? And so we defined two statistics that we thought told us something about connectedness. When you're almost flat, we're about 80% there, okay? I prefer 90% because I don't like to take a lot of risk. And what we found is that this cutoff point of a value of 0.10 in connectedness of values between different flocks gives us reasonably good assurance that the breeding values of the animals in one flock, when I compare to the animals in the other flock, are robust. If I make decisions on that data, I'll be doing a pretty darn good job. Okay? And so our magic number is this 0.1. So I want to show you some data. Again, you'll see a lot more in practice in the workshop sessions. These are called tree diagrams or dendrograms. I've got that connectedness value along the horizontal axis. I have flock codes along the vertical axis, okay? And I'm going to draw a line. That's my magic 0.1. So basically, anytime branches connect to the left of that red line, I feel pretty good that I can compare animals in those flocks, okay? Feel pretty good about it. And it turns out that if I do that, I have formed basically 3 clusters of flocks within which those branches are all higher than 0.1. And I feel pretty confident in making comparisons among animals that are reared in those sets of flocks. 5 years later, same set of animals, same flocks, same cutoff point. Notice what has happened. So over time, some of the flocks have connected to the larger cluster. There's still a couple flocks that are doing their own thing together, and one flock that doesn't like anybody, okay? All right, so what you see is that over time, connectedness is improving based on the exchange, usually fairly serendipitously, of rams, okay? So connectedness is improving. These are real data on some of your flocks, all right? So that's how we are evaluating connectedness in practice. And we'll be talking about similar figures in all of your different breeds later on this afternoon, okay? So I'm going to sum up in the couple minutes I have left. Connectedness is really important when we're trying to make selection decisions among animals across flocks because we need to disentangle genetics from environment. If connectedness is insufficient, we just need to be careful if we're making the right choices in those comparisons. It can also be used to define some dynamics of breeding programs. When we see disconnected groups, it usually means something. They have different objectives in their breeding programs, and that maybe needs to be thought about. And I've actually also used it to figure out who I want to genotype, similar to some of Carrie's comments about some of the tools that she's using. Increasing connectedness is not a goal in its own right. I'll say that again and again. It is not a goal in its own right. But if we're carried away with that, we lose our vision on where we want to go in our breeding programs. You can connect flocks with the most horrible animal in the world. It doesn't care, right? But that doesn't help our bottom line, okay? However, if it's tenuous, it probably is worth implementing strategies that help us deal with that. One example is to source rams from well-connected flocks with a long history in NSIP, and I think that was an answer to one of a question earlier on that somebody asked about how do I apply genomics information in general. Okay, so with that, questions that you may want to ask because I maybe can answer them, or anything else that you wish to ask at this point in time.
When you see Ron's tree diagram, you automatically judge that pair. It's important now. It's a pair of flocks that are the most connected. And your eye automatically gravitates to who's the most connected, second most connected. It's only the connection between those two flocks that's being measured. You got to go back out towards that red line to really understand how well are those individual flocks all working together as a connected group. It took me quite a while to get my head around that. I had to stop looking at those the individual diagram.
What it's doing is saying this is a cluster of which I'm comfortable in saying their breeding values are comparable to mine, and therefore I'm comfortable with selecting animals from their flocks.
the one I learned working with Ron on this is that it's all about pairwise comparisons. It's all about comparing 1 to 2 and 1 to 3 and then so on, and then 2 to 3 and 2 to 4 and 2 to 5 over and over and over and over and over. And that's how you arrive at this tree diagram. So what it means for 15 and 17, 15 isn't the most connected flock. It's the most connected flock to 17. That's what it tells you. And that has value if you're 15 and 17. But it doesn't have a lot of value if you're 14. So that's my take on that.
Relates to also what Dr. Frecking was talking about earlier. We tend to hold on to our information and not tell anybody else because some of it is a little bit condemning at times or concerning at times. But if they don't know what flock you are, right, there's no way they can make a decision about purchasing animals from you. My comment about Dr. Frecking, right now, the only people that get our genetic condition report is the person who submitted the test. It's not reported anywhere else in our industry. So if I'm looking for rams, unless you talk to an individual, that information isn't available on the searchable database or NSIP or anywhere else. So like every other species that use this tool, do we not need to move towards reporting, not that we just did genotyping, but what the results of those genotypes were so people know what our animal happens to be?
Database to not know this. So we can go out and search and find out what the EBVs of all these animals are, but if we don't know their connectedness, that decreases the value, tremendously decreases the value of the searchable database.
I would agree, but I'm one biased individual here. So if we want to extend these ideas, do we somehow need to get an agreement, some way, of flocks who are willing to share who they are on these kinds of plots? There may be some who opt out, that's a choice, but having a way to share that, and again, I think at the same time we should debate about reporting genotype information, genetic condition information. I think it'd be a really valuable outcome of what we do today and as part of sheep gens.
We have the same discussion on searchable database. And there was people that didn't want their numbers shared, that thought it was private information. The information that's private is the raw data. The NSIP or the EBVs, that's public information is what NSIP as a board decided, and I think this is the same thing. Raw data is my business. The numbers that come as a result of it in this format are public information. If I don't want you to know that stuff, I need to not submit it. I mean, that's an understanding. If you're going to be part of this, the world's going to be.
Okay, I think that, when we take animals to NSIP sales, we willingly provide all that information. So what's the difference than not wanting it in a searchable database? I mean, when I go to an NSIP sale, we make all that stuff public. So what's the difference?
Yeah, so I would say, and I don't know your name, but I remember you from last year. I'm Dan. Okay. So what Matt, I think, is saying, are you saying, why shouldn't we know who people are on the rungs? Because realistically, those EBVs are almost meaningless if you're not connected. They're in flock EBVs. So I would probably be more prone to want to buy from a flock that is higher than 0.1. So I think it would do us a service if we're really trying to improve the genetic merit of our sheep to know that we are at the right level of connectedness to be getting what we think we're getting.
If I may, but curiosity, maybe Brenda, how do we get there?
The accuracy value is impacted by connectedness.
Same thing. We have a sire, produced 100 progeny, right? You can produce 100 progeny in one flock. I guarantee it's going to have a high accuracy of its EBV. I can take those same 100 progeny,
Okay.
separate them across 10 flocks, and that sire has 10 progeny in each of 10 flocks. I guarantee its accuracy will be lower because I'm breaking the data up by those flocks.
And just shy of releasing it, could there be a connectedness index? So that you know, buying from somebody who is a 0.7 and it's a published index, or a 0.07, is not going to be the same as buying from somebody who's a 0.3.
And in what sense?
That would just have to do with connectedness values.
I mean, what we can do, and I decided this is what has run out of the United Kingdom when I proposed it, was I can provide pairwise values for every one of those flocks. That's what we work with. So basically I look at the relationships of every individual animal. I draw it together by flock to create figures for all pairwise comparisons. So if we think about that, there would be 14 times 15 divided by 2. I have no idea what that answer is, but that's what it was going to be. Possible pairwise comparisons with just that set of flocks. Currently, with the Katahdin, there's 107 active flocks. So that would be 107 times 108 divided by 2 possible pairwise comparisons, which we could give. And people could look down and say, I'm interested in buying from that flock. What is my connectedness index, if I may, to that individual flock? The feedback I got was that was too much for people to want to interpret.
You put this value basically is an index. Yeah, it already is an index. Right. Connectedness, you're not value. You don't want to turn it into something else.
So I'm told I'm going to fall through the floor here by our timekeeper. It is break time, but we can either stop or entertain another question. It's up to you. Any more questions that are pressing?
Can I make a point?
Please.
I want to follow up on Matt's point about we're already publishing the breeding values, and it's the raw data that are intellectual property. I think today's discussion and what Ron's been talking about here specifically is there's really two different things. There's the possibility of the genetic conditions being made public, and there's possibility of the connectedness value being made public. So with the connectedness value, that's very similar to the EBVs because it's a calculated value. There's no raw data there. But with the Katahdins, there's 107 of them, and there's 6 clusters, and one is a large cluster made up of a lot of flocks. There's obviously incentive for producers that are in some of these larger clusters to want to release the information. So there's a financial incentive there. So there's people who aren't in those that might want that information, but could be critical of those flocks releasing that information for financial gain. The second thing is with the genetic conditions, I would argue that is raw data. Just to be devil's advocate, that is raw data. I'm not opposed to releasing it, but at lunch we had this discussion, well, what wouldn't you want released? Well, how about if you had calopecia in your flock, or in one case I'm aware of, an AV animal, AV at 136, which is rare, but you wouldn't want to replicate it at this point because it's rare. So those are the sorts of things that could be touchy. That not all genetic conditions are good. Some are bad. We may come up with others in the future that are bad. And if we have, I'm sure that was the case with some of the cattle issues. So those are some things to think about. So it's not all, I don't believe that's all a matter of no raw data involved. I think there is we need to consider seriously about releasing the genetic conditions. I'm in favor of it, but it does carry some risk. And then in terms of the connectivity, I can just hear the complaints rolling in about, you release this information, but you stand to put money in your pocket, blah, 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 the same thing, so. There needs to be some serious discussion at the board level.